So let's start with power and exponent, okay? So let's say if we have a variable here a, and let's say that a is a real number, okay? And n is a positive integer, okay? Then a to the power of n, this actually means a times a times a times a. How many a's do we have here? N times, okay? If we have to the power of n, then we have n number of a's here. This a here is known as the base, n is the exponent. How do we read this? A to the power of n. Okay, so a to the power of n means n times the power of 2 as 5 to the power of 2. 5 is the base and 2 is the exponent. This is 5 times 5. So you have a to the power of 5 is a times a times a times a times a. A to the power of 2 is a times a. Okay. So if you understand this, then we can look at laws of exponents. Okay, laws of. Anytime you want to ask me, okay? Laws of, okay? So let's look at one example first. A to the power of 2 times a to the power of 3. What does this mean? A to the power of 2 means a times a. Times, okay? Times. A to the power of 3 means a times a times a. So how many a's do we have here? 5. So this is a to the power of 5, okay? So we know that a to the power of 3 is a to the power of, how do we get this 5 here? It's power of 2 plus 3. So a 3 is actually of 2 plus 3. Okay. This is how we develop the laws of exponent. Okay. So we have a to the power of 3 divided by a to the power of 2. A to the power of 3 means a times a divided by a to the power of a. Okay. We simplify this, we have a. Therefore, a to the power of 3 divided by 2 is a to the power of 3 minus 2, which is a. Okay. Okay, so far. Okay, a to the power of 2, and we have to the power of 3, okay? So this is actually means 2 times a to the power of 2 to the power of 2. 2 is a times a times a times a. So now we have 6 a's here, so it's a to the power of 6. Okay, therefore a to the power of 2 to the power of 3 is equal to a to the power of 2 times 3 is equal to a to the power of 6. Okay, so you need to understand, forget, is it times or is it plus, so you can develop law by yourself. Okay, if you understand this, then let's the laws of exponent, all the laws of exponents. Okay, let's say if m and n subset of q, q is integer and a is subset of r plus, these are real numbers. First law of exponent is a to the power of n, the power of m plus n. Okay, exponent is divided by equals to a to the power of m minus n. Third law, a to the power of m to the power of n is equal to a to the power of m times n. Okay, or we can just write it as a to the power of. Okay, so there are a few another. Okay, fourth law that you have to know is power of 0 is 1. So anything to the power of 0 is all 1. A to the power of negative n is 1 over a to the power of n. Okay. A to the power of 1 over n is root n. Okay. Root n. And final power of m over n is m, or you can write it like this: a, the whole thing to the power of m. No, to answer any questions on exponent. Okay, so far? Okay, let's look at some examples. Okay, find the value of 27 to the power of 2 over 3. So you know 27 to the power of 2 over 3 is what? Root what? Is 3, and either you can put it here, or yeah, it's easier to put it like this. Okay, square. So find the root 3 of 27 first. Okay, cube root of 27 first. So cube root of 27 is 3. Yeah? 3 times 3, 9. 9 times 3 is 27. So cube root of 27 is 3 to the power of 2. Therefore, this is 9. Okay. 0.25 to the power of 3 over 2. When you have a decimal like this, it's easier to change it into fraction. So 0.25, if we change it into fraction, it becomes 0.25, 2 decimal places. Therefore, this is actually 25 over 100. We can simplify 25 over 100 to 1 over 4 to the power of 3 over 2. Therefore, this is so when we have a fraction like this power is for the denominator and the numerator. Okay, so that means this actually means 1 to the power of 3 over 2 over 4 to the power of 3 over 2. 1 to the power of anything is 1. Okay, so now we have 4 to the power of 3 over 2. This is actually square root of 4. So this is 1 over square root of 4 is 2. 2 times 2 times 2 is 8. So the answer is 1 over 8. Okay. Any questions?
No.
So far clear, madam.
Okay. So number 3, 16 over 81 to the power of negative 3 over 4. What is the first step? How should we write this? How do we make this positive? Anyone? When you have a negative power, a to the power of negative n is equals to 1 over a to the power of n. Okay, so if we want to remove this negative, we can write it as 1 over 16 over 81 to the power of 3 over 4. I'm showing you every single step. You, of course, can skip some steps later. Okay, so what does this mean? This actually means it is 1 over the numerator and the denominator is to the power of 3 over 4. That means 16 to the power of 3 over 4 over 81 to the power of 3 over 4. Okay, 1 over 16 to the power of 3 over 4 divided by 81 to the power of 3 over 4 is 81 to the power of 3 over 4 over 16 to the power of 3 over 4. Okay, so this actually is 81 to the power of 3 over root 16 to the power of 3. Okay, so to solve this, we have h1 root 4 is 3 to the power of 3 over 16 root 4 is 2 times 2 times 2 times 2. So it's 2 to the power of 3. So this is 27 over 8. Okay. Okay, question 4. Find x when 9 to the power of x is 27. You want to find x. When you have an equal sign here, that means you need to solve it. Okay, solve for whichever variable is given. So 9 to the power of x equals to 27. You want to find x. So look at both these numbers. They are compatible. You know that they are both can be written, can be converted to base 3. So 9 can be written as 3 to the power of 2. And then you have the x there. 27 can also be written as power of 3. This is 3 to the power of 3. When the base is the same, okay, because the base is the same, therefore, both the exponents are also equal, okay. Therefore, 2x is equal to 3, x is equals to 3 over 2. Okay, so anytime you see the same base, it means the exponent is equal. Okay, question 5. Simplify this. 32 to the power of 3 over 2 multiplied by 2 to the power of negative 3 over 2. You want to simplify this only, okay? So how do we simplify this? We want to use the laws of exponent, but the base is different. So we want to try and make the base the same. So 32 we know can be written in base 2, okay? So 32 is also equivalent to 2 to the power of 5. Then we have the 3 over 2 here, multiplied by 2 to the power of negative 3 over 2. Now we have both same base. If we have both same base, then we can add the exponent. So this is 15 over 2 plus negative 3 over 2. So this is 2 to the power of 15 minus 3 is 12 over 2. So this is 2 to the power of 6, which is 64. Okay, so we have simplified this using the laws of exponent. Okay, I finished with exponent, power and exponent. So power and exponent, we will use a lot in logarithm. When we do logarithm, we will be using a lot of these laws of power and exponent. That's why the topics come together. Okay. Any questions so far?
No, madam.
Okay. Okay. So these are the laws of exponents that you must remember. Okay. If you remember this, you can solve any question. Okay, so now we are finished with the power and exponent. Oh, sorry. So now we're going to continue with logarithm. Okay, so the definition of logarithm, if y is equals to b to the power of x, okay, then log y base b is equals to x. Okay, this is the definition of logarithm. If y is to the power of bx, then we can write this in the form of log, like this. Okay, if we put a log in front of y, then we need to bring the b as the base. So log y base b is equals to x. Okay. Okay. some rules for logarithm. Log of 1 base b is equals to 0. It doesn't matter what b is. B can be any number, but log of 1 is always 0. Okay? Log b base b is equals to 1. If the number and the base is the same, logarithm is always 1. Okay? In log b base b, log b to the power of n base b, this is equals to n log b base b, but we know that log b base b is 1. Therefore, this is n times 1, which is n. Okay. Log xy is base a, yeah? This can be anything here. Log xy base a, we can expand this as log x base a plus log y base a. Okay, so this can be expanded like this, so only if it's multiplied here. Okay, log x over y base a can be expanded as log x base a minus log y base a. Okay, so if multiplied, you add. If it's divide, minus. Okay, and log x to the power of n base a is equals to n log x. So anytime you have an exponent, you always bring it to the front. Okay, the last one is if you want to change the, say you want to change the base to b, so this is equals to log c base b over a base b. Okay, these are important rules for logarithm. Okay, so this is what we need to memorize. Okay, if you have log, say log 10 to x, okay, this is also equivalent to log 2 base 10 plus log x base 10. Okay, this is how we apply the rule, first rule, this rule here. Okay, so log 2 times that, because this is multiplied, we can expand this like this. But if you have something like this, log 2 plus x base 10, this is not the same. Okay, this is not the same as this, so don't make a mistake. When you have 2 plus this like this, then you must assume that this is 1. 2 plus x is 1. Okay, one variable, 2 plus x. Okay, you cannot break this up. Okay, so don't make mistake here. Okay, so if you look at this, if you multiply or divide, you can expand. Plus minus cannot expand. Okay. Okay, let's do some examples for log. Okay. Okay, question 1. Find the value of log 343, cube root of 343 base 7. Okay, how do we do this? What is cube root of 343? Okay, let's remove this cube root first. Okay, if you want to remove this cube root first, we don't have to do that, but if you want to remove it, we can write this as 343 to the power of, anyone? To the power of? Square root of 2 is the same as 2 to the power of 1 over 3. Cube root of 3, cube root of 2 is equals to 2 to the power of 1 over 3. Okay, this is how we convert. Just now we saw already. Okay, so this one we can also write as 343 to the power of 1 over 3. You can write that. Okay, so 343 is also equivalent to 7 to the power of 3. 1 over 3. Okay, so you cancel these two, you have log 7 base 7. So the number and the base is the same. Therefore, log 7 base 7 is equals to 1. Okay. Cube root of 100 base 10. Okay, how do we do this? What is cube root of 100? You don't know, so rewrite this as log cube root of 100 is 100 to the power of 1 over 3 base 10. Okay, so 100 is also, we can also write it as 10 to the power of 2 to the power of 1 over 3. So this is log 10 to the power of 2 over 3. So when you have an exponent, you can always bring it to the front, okay? So this equals to 2 over 3 log 10 base 10. You know that log 10 base 10 is equivalent to 1. So this is 2 over 3 times 1 is 2 over 3. Okay? So for okay?
Okay.
Okay.
Okay, question 3 here. So we have log root 81 over root 27 base 3. Okay, so if you know this here is base 3, then you must try and write these numbers in terms of 3. Okay, so we have log divided by a number divided by number. So using the log rule, we can expand this as log root 81 base 3 minus, because it's divide, so it becomes minus log root 27 base 3. So we have log 81, root 81 minus root 27. Okay, so this can also be rewritten as log 81 to the power of half minus 27 to the power of half. Okay, square root becomes to the power of half. Okay, so because the base is 3, try to write 81 as base 3. So this will be 3 to the power of 4, right? 3 to the power of 4, power of half minus log 27 is 3 to the power of 3 to the power of half. Okay, so what do we have here? So we have log 3 base 3 to the power of 2 minus log 3 to the power of 3 over 2. So we have 2 log 3 base 3 minus 3 over 2 log. Okay, so log 3 base 3 is 1, log 3 base 3 is 1. So we have 2 minus 3 over 2 is 1 over 2. Okay, do you understand this? Anyone will understand this question? Okay. Okay, I'm going to do a few more, okay? Um, okay. Okay, so you're given an equation like this and you're asked to find x. Okay, so how do you find x? Okay, so we can rewrite this, log x to the power of b. Just bring the right to the left and the left to right, okay? So this one, log 4 to the power of b, 2 log 4 to the power of b, okay? We can also write this as log 4b 4 square, okay? Bring the exponent up, so we have 4 to the power of 2 plus log 5 base b minus log 10 base b. So you notice that all the base is the same, okay? If all the base is the same, then you can easily solve this, okay? So this is also equivalent to log plus log. When we have log plus log, then it becomes log b 4 squared times 5, okay? And we have minus 10, so this is over divided by 10. Okay, so whatever's on the right, we can simplify it using the log rule. Okay, plus becomes multiplied and minus becomes divide. Okay, so from here we have log x base b is equals to, solve this, we have, this is 4 to the power of 2, 16. 16 divided by 2 becomes 8, okay? So we have log 8 base b, okay? So this is log, base b. So we have log on both sides and the base is the same. If the base is the same, then these two numbers are equivalent. Therefore, x is equals to 8. Okay? Question 5. Same thing, find x if log 30 base b minus log 5 to the power of 2 base b is equals to log x base b, okay? So log x base b is equals to, I'm just rewriting the other side so it's easier to solve. But if you can do it straight, do it straight. So we know that log x base b equals to, we have log 30 base b minus log 5 to the power of 2 base b. Both the bases are the same. So log minus log is log, divide by log, okay? So this is log base b 30 divided by 5 to the power of 2, which is 25. So I'm going to write here 25. Okay, therefore we have log b here and log b here, therefore x is equals to 30 over 25, which is 6 over 5 or 1 over 5. Okay, this, we are solving this using rules of log. Okay, Okay, so this question we want to solve also for whenever we have an equation, that means we are solving the equation for the variable given. So now we want to find what is x. Okay, so how do we do this? Okay, so let's solve this one first. So let's rewrite this as log 3x. We bring this to the left first, equals to log bx plus 2 minus log 4 base b. So on our right here, this is log minus log. All the bases are the same. So log minus log becomes x plus 2 over 4 divided by 4. So far, okay? Can you follow until here? Yes?
Yeah.
So because we have log b here and log b here, therefore 3x at this stage you must be able to see the equivalence. So 3x x is equals to x plus 2 over 4. So 12x is equals to x plus 2. So tell me what's the answer.
2/11.
Okay, so 12x minus x is equals to 2, 11x is equals to 2, x is equals to 211. Good. Okay, question 7. Log 8 plus log x. We have log 8 plus log x to the power of 2. So when we see a plus there, you know we can combine it. Okay, so we have log x to the power of b is equals to log 8x square base b, correct? See how we got this? Because we have log plus log, so we times it. 8 times x to the power of 2. Log and log same, therefore from here we know that x is equals to 8x squared. Okay, now you tell me what's the answer. Anyone?
1/8.
1 over 8. Any other answers? Okay, sometimes students do this. They cancel this, so they have 8x is equals to 0, x is equals to 0. Okay, so it cannot be done like this. So what we do is to either bring it onto the left or bring it onto the right. So 8x squared minus x is equals to 0. When you have like this, you need to factorize. Take out the common factor. This is x. So this 8x minus 1 equals to 0. So we have two factors here. X is equals to 0 or 8x minus 1 is equals to 0. So x is equals to 0 or x. So there are two answers. X is 0 or x is 108. Whenever you see this kind of, you come with how you solve it. You must factorize it, okay? You cannot just eliminate the x by cancelling. Okay. Okay, same question. Almost similar question. We want to find x. So log x base b is equals to, because we have log plus log, so we can multiply it. X minus 1 multiplied by 3. Okay, so from here we know that x equals x minus 1. So x equals to 3. So bring it on to one side. Minus 3 is equals to 3. Yeah? So here, take this over here. Okay, x is equals to 3. X is equal over 2, which is 1 over 2. Okay, so you can do this. Okay, easy. Okay, let me do just 1 or 2 more examples. Okay, then we simplify this. 8x to the power of 1 over 3. We want to simplify it to the most simple form. Okay, so when you have something like this, when log, you have an exponent, the most natural thing is to bring it to the front first. Okay, because we're not solving, we're only simplifying now. So this also equals to 1 over 3 log 8x base 2. So then you see, look at this. Okay, this is 8x, 8 multiplied by x, 8 times x. We know that times we can expand it. So this is 1 over 3 log 8 base 2 plus log x base 2. Correct? Okay, so now you want to simplify it further. Look at the base is 2. So x, you can't do anything about it, but 8, you can change it to base 2. Okay, so that you can simplify it further. So 8 can be written as 2 to the power of 3. Okay, so this is 1 over 3 log 2 to the power of 3 base 2 plus 1 over 3 log x to the power of base 2. So bring the exponent to the front. We have 3 multiplied by 1 over 3 log 2 plus 1 over 3 log x base 2. Okay, so this is, cancel this 2. We have log 2 base 2 plus 1 over 3 log x base 2. So log 2 base 2 is 1 plus 1 over 3 log x base 2. Okay, this is the simplified form. Okay, so we're using logarithm laws to simplify this, the laws involving exponent and addition. Okay, I think it's enough examples. So this topic, power, exponent, and logarithm, is quite a simple